Yeah, hello. Yes, good evening. Uh,
Evenings.
Welcome to the live session for the eighth week for the course of Statistic for Biomedical Engineers. Uh, I am MD Aziz PMRF Fellow at University Tripoli, and we are discussing about the full outline of the biostatistic that is going to use for that is a statistic for biomedical engineers. And today we'll have statistic will discuss, but we'll try to connect with the machine learning also. I'll give some brief like how it's going to be uh, applicable in all. So till now, can you just tell like any doubt or anywhere something that you feel difficulties and all that I can explain a bit more? Can you please tell like that my voice is audible, no?
Yes, sir, audible.
Yeah, thank you. Or any doubt is there?
No, sir. Last week it was okay. Thank you, sir.
Okay. So I think till now we have discussed something called started with the descriptive statistic, then we entered into the central limit theorem, that's the versatile or what we can say universal testing. After that, we moved to the sophisticated test like t-test and all. Then we discuss when we are going to define the inferential statistics. So we are what is the hypothesis and all that we have discussed also. What are the element of the hypothesis also we have seen like that's the null hypothesis, then alternative hypothesis, what is definition, then we have seen the confusion matrix also, type 1 error, type 2 error we have seen. Then we tell about like what is the p-value and then what is the power of the test also we have checked it out. Then we came to the contingency test also. Then we check for the chi-square test once when we have the positive or skewed distributions was there. And then we went to the t-test also. After that, we check for the because the idea is in the hypothesis or statistic is to check the mean differences and all in any population. Either it can be one group or two group or three group. If we have two groups and that the number of sample is less than 30, in that case, what we are saying, we are just going for the t-test and we are checking some assumptions also like whether the data should be whether that data should be linear and okay. So we were discussing about the test, the statistic test and all. Then we checked about what are the elements of the test. Was the hypothesis is testing like what is the element, what is that going to be null hypothesis. So it's a status quo that will tell. Let's say I'm going to compare between two medicines and all that. I'll say no, there is no changes was there. That was the we check for the null hypothesis, and that the our main agenda or that the goal will be we have to reject the null hypothesis in any circumstances or any cases and all that we not say like we're going to accept the null hypothesis. That word itself is a something we call that is not correct, that not valid actually. In by chance or something that if the data is very smooth or something that there's no much of difference came, so we'll tell we don't have enough evidence to conclude or uh, to reject the null hypothesis. Okay, so we'll not say that I'm going to accept the null hypothesis. Something we're going to say we don't have enough evidence to reject the null hypothesis. Okay, then we have check what is the p-value. It's a probability of that's the region that we have to do the we have to don't need to consider. Then power of the test something that power any test will give some 80% for the power calculation and all, or maybe the sample size calculation also we have g power software is there that we can calculate and all. Then we move to the chi-square test. Chi-square test also like we have when we don't have the negative side of that or skewed to the positive skewed distributions and all. After that we move to the till now we were discussing about the mean. Then sometimes the mean will not give the alone picture of full statistic or full problem estimate. So we have to go with the Hypothesis. No, it's a variance. So for the case of variance, we have the F test that we have discussed also. Like what is the F test? Like they're going to check with the instead of going with them, and that's the main goal will be to compare the mean differences only. But the test parameter or test statistic they will deal with the more of variance parameter. So if that then the F test came, then we have checked with the paired t test. Then put that there's a pool t test we have checked also. After that, that all the tests that were having some sort of what you can say that the conditions were there that the group should be two or single group or two groups should be there. So that means we can take the sample from the that the populations and all. So when we have a different types of samples are there, let's say instead of two, that's the two drugs we have three, that the three drugs are there, four drugs are there, five drugs are there. So what we'll do in that case, we'll check with the because the in that case if we going to pair it with the two groups and we'll do again, so there is chances of the error type one error will increase, and sometimes they will give the bias results and all. So we can't do, and what will happen when we have something called 5C2, like that let's say five groups are there. So that's the total number of combination will be something 5C2. Like so in that case, number of tests will be going to increase. It's a computational test will increase. Instead of going with the what we can say traditional method, we came across the ANOVA. That's we call analysis of variance. In that case, they're going to allow more than one. That's more than two. The what we can say two some sort of parameters and all, or the groups or populations and all. In that we have, that we have checked about some parameter like that's called mean squared error, and then we have checked about the what is the error and all. Then we have checked some problems and also. So till now we have discussed about the ANOVA and all. So now this is the one way ANOVA we have discussed as such till now. So today, so after that there will be chances will be there two-way ANOVA or repeated measure ANOVA we can go. So that the before jumping into that two-way ANOVA or something other, so we have to discuss more about the linear regression. Linear regression, or we'll say regression. Regression will be again part of in that will be having going to be near. That's going to be what is that's going to be linear. Then it will go to the multilinear, and then third will go nonlinear. Then we'll go to the multivariate. Then we'll go to the that's the logistic regression. Okay, so actually this part is part of the machine learning. What is the machine learning? Can anyone tell? Machine learning. Okay, before jumping, before I'll go into the pure regression or to solve the problems or maybe the statistic or confidence interval that what we have done for the t-test or the that what we can say one way ANOVA and all. We'll discuss more about the machine learning because of in the machine learning actually the agenda is to do the classification or the regression problem or the predictions. So this in the classification or the predictions that's the regression is going to be a play more part into the picture. So can anyone tell what is the machine learning and how that can be defined and all? Machine learning is something like yeah. Tell me, just read it out and then tell me like how can we define it all, or maybe any of the layman language. Anyone?
Not so clear, Sasa. Better. Can you explain?
Sorry.
It's not so clear to me, so you
Okay.
explain once.
So in the machine learning, we have two words. It's a learning and then machine. Machine is something that we told like it's going to automate the process or it's going to make the easy. Learning is something that whatever the existing stuff we have, it's say let's say learning. So it's a teaching learning process. It's the similar way. A machine, so they're going to learn from something that we call data set, and we have to classify or predict it. So that the whole process will say that what is a machine learning. It's something a machine learning program computer to optimize the performance criteria using example data or past experiences. Something first we have to learn or we have to teach the machine. Then they are going to for the case of that the Flipkart rating and all, whether it's a 3, 4, 5 and all. So that rating will comes under the uh, reinforcement learning and all. The thing is that what they are doing, they are just classifying the data set. That for the certain criteria. Let's say uh, a man is happy. In what case? Let's say they are something in the age of 10, 20, 30. Some characteristic will be there. And for a man, it will be going to be like different types of data set will be there. 10, 20, 30, 50 will be there. For the 10, we'll be having some features will be there. With the 10, we have some features will be associated. Features is something we'll call properties will be there. And for the B also something that the second person, third person, fourth person will go. Some characteristic will be there. Then after we'll say these are the data that is going to available, and then we'll say like for this characteristic, how many persons are is going to be happy, how many person is going to be sad or something like that. We will tell. It's something we have a model defined up to some parameter, and then we are going to execute the computer program to optimize the parameter to the training data set or past data experiments. So in when we'll talk about the machine learning, so we'll talk more about the data set. Data can be the imbalance. The data can be it can be the what you can say that the noisy and all. So it's something that we have to deal about. So that the main task is to when we are going to do the machine learning, that's will be data cleaning, because the data will be not always like clear. Let's say for the case of that the Flipkart rating and all, sometimes the data will be not clear, or maybe I'll say I'm taking any of the wearable devices and all. So sometimes data will be not clear and all. In that the data we have to segregate it or we have to categorize it. In the machine learning also we have different types of machine learning are there. So that's the supervised, what is the supervised, unsupervised. Then we have what is the semi-supervised. Then we have the what is self-supervised also is there. Okay, so in the machine learning or maybe the field of AI, artificial intelligence, it's a creating the intelligence machine to mimic the human intelligence. It's a broader part. In the AI, it will come the machine learning that the algorithm enables computer to the learn from the data. So the in the machine learning, we are going to play very crucial part like a statistic will play a crucial part because we have to generate a algorithm or the probability that it's going to run it out or to make the decision and all. So that will comes under the something called the machine learning. What about the it's called? Then we have that NN. NN we call neural that we call that neural network. So it's a part of the human brains and all. They are going to mimic just try to just that the similar way what we are try to that our brain works and all. Then we have that deep learning. Deep learning is something that we are going to play with that's what we can say. That's the multiple layer for the hierarchical representation learning, that learning and all. It's the broad that the machine learning and all that we will not go much into that. Just we will touch that the part of what we can say. It's going to regression only. So in the regression also we'll be having the classifications also. Then we'll have the predictions also. Classification is something we'll do the categorization, and in the regression we'll do some sort of predictions. So if we talk about the theoretical definitions of the what we can say machine learning, a computer program is said to the learn from the experience. How come that will going to experience some data set with respect to some class task T? We have some sort of data or task will be there. Based upon they're going to learn from the past experiences and performance P. If its parameter at task T as measured by P improved with the experience E. Something from the learning itself, whatever it was there, to categorize or to segregate the data and all. So their improvement is, or that the performance will going to increase. So that the whole process will call machine learning. Okay. So we'll see some examples. I'll just keep it down here. So first example is that we are going to handwriting recognition learning problem. So task will be we are going to recognize or classify handwriting within the image. Let's say that the one person has some cursive writing, then second have what we can say that normal and all. Then performance that percentage of the word correctly classified. Then training experience will be a data set, a handwritten words with the given classification. In that also we'll have the 5 word, 10 words, 15 word. In that also it will be there, something will be there. So it's that type of problem. So that a problem, so they will going to so they will learn it and then classify it. After that, we have a robot driving the learning problem. Task will be driving on the highway using the vision sensor. So they are going to collect data, vision sensor. What will the performance measure P? Average distance travel before an error happen. Then training experience will be sequence of the image or a steering command that is going to record it while observing the human driver. It's something, a car is there, we have the car. Okay. So any of the that the robot is there. So they will going to see they will see the image or steering commands and all. After that, they will check what is the training and all. Then based upon that, they are going to predict. Or that's why in in current generation cars and all, it's AI or self-driving car. That the self-driving car. So this is all part of AI only. So that the first step we will have the data. From the data or the things we are going to define some sort of hypothesis or something that we have to learn or not. Then we have the black box or generalizing that we're going to apply some algorithm. Then we are going to evaluate it. Okay. So where we use? We can use for the retail business just to study the consumer behaviors and all. Or maybe the finance also we can use bank analyze their past data to build model to use the credit applications and all. Let's say a bank is there, so they'll try to figure out like whatever the card they have say that sell or their card issued, how they are going to be like it's going to play that the market and all. Based upon that, they're going to build a model or they'll make some campaign and all. So they are so they will use the machine learning also in the manufacturing. They'll use the optimization, control, or troubleshooting. Let's say that till that 20 year and all, it was the all that's going to be manual. But now what we're doing that we have the robot. So they will do the welding. In that now CNC machines are also there. CNC machine is called semi-automatic machines and all are there. So it's something that we'll play. Then we have in the medicine also learning program are used for the medical diagnosis also. Even and that nowadays AI also, if you give some symptoms, some criteria, age criteria and all, they will try to figure out okay which type or what is the stage of that particular disease are there. Let's say a doctor they have finalized it some diseases there, some one disease one. So now, if you have some features or same is some sort of that symptom, you will give it to the AI model. So based upon the features or something, they will going to categorize what type of severities you have. First, on the category of like it's going to mild or severe or it's going to critical and all, they're going to classify and all. In telecommunications also call pattern are analyzed for the what we can say quality of service or maybe the network optimizations also. So I can say in what we can say that the nowadays every application, every field, the people are using the AI and all. And the whole is and actually what I can say, don't like I'll just give the brief and all. It's something where it's going to use and all. This course is actually a fundamental for to enter into the what you can say uh, in the field of machine learning. So that's why I'm just giving the brief because that before starting to the regression, we should have the idea like how it going to use and then where we can use it and all. Then we have the science also. A physics they can use the data or astronomy data, biology they will going to just like a worldwide weight that's the WWW. Okay. So they will going to. So nowadays we came across the LLM model, large. That's the we are going to play with the Chat GPT, OpenAI, and all are there. So they are working on the LLM model and all. What they done? So it was a WW. It was the World Wide Web. It was a something we call manual. We have to do something and then it will come. But now it's a fully automated based upon the conditions and all that you will going to get in all. So it's something. It's a filter the things that coming out. Then we have the artificial intelligence to something to learn or mimic the human participants and all, or to find the many problem solution in the that the vision, speech recognition, or the robotics. Even I'll say exoskeleton or maybe the prosthetics in the field of biomedical and all. Even we have the medical reports are there. How it was done. That's all that what you can say hardware and all that was taken with the help of what you can say for the like from the patient that the patient, even the paralysis people also they can use with the prosthetics or maybe uh, skeleton, so they can run and all. Even we can do the speech recognition also. Even let's say that we can do the vision problems also. That the vision problem is like a gate problem. A person will run when we can see and all that we can do. Machine learning that can be design of the computer controlled vehicle to the steer correctly when the driving on the variety of the road. It's something that Tesla came across with a self-driving car. That's the single car that they're playing in the world now. Then we have a that the machine learning used to develop a program for the playing games also, even the casino. So they're going to the chess, that's the backgammon and all. Even the people nowadays, I think the government of India has banned the Dream 11 and all. They were all playing with the machine learning and all. And you know that the percentage of chances of the winning is something that 0.0001% only. Even the 1 crore people, only 10,000 people have won the something called prize. Otherwise, all were in loss only. When the after the ban, they have that they release the data. So it's something they're playing with the data and all. They are manipulating with the people and all. People were thinking they are going to play some. So they will keep some money and they will going to get some earn the money. But what's happened? It's something. It's a very manipulative and all that good player. So they are earning much more money. But people those who are playing with that, so they're going to lose. So that's why even if someone knows the mathematics, machine learning, so they can play a casino or maybe the stock market or any of the gambling game and all with the help of mathematics and all. But it's very difficult because it will come something we called that the moving average methods and all. Then the time series methods it will come into the picture, or maybe that's the what we can say that stick or maybe the candle and stick in the stock market and all. It's a very difficult. We have to play with the statistic. We should have the very good idea of the probability statistic, then the machine learning. Then we can play a good part of that. That's why in the economics or finances, the people will use more and more of this. And so that the same thing they are transforming into the biomedical engineering and all. So if we talk about what is that algorithm actually, so we'll talk about the supervised learning. Supervised learning, can anyone tell what are the differences like supervised? So supervised is something I'll give the brief. Like supervised something that we have already classified the data. We'll tell one group this much, second group like this and all. So supervised something that we have already clustering that a cluster of the data already done. Classification, not classification, is something the data is already categorized, we can say. So in that also we have the regression. That the regression is something we'll do. We have this one and then straight line, then the data will come here. So it's called the predictions and all. And then we'll talk about the more about the error. And we have the classification. Classification will be something we're going to classify either 0 or 1. In the case of binary and all, multi-class will be something like we have to classify 3 to 4 pattern and all. That the let's say I'm saying a person run for that treadmill. They have run until it got fatigued out. So now I have to classify this is going to be non-fatigue zone. Somewhere it's going to be a fatigue progression, and the last when it's going to stop out, it become fatigue. So it's become multi-class problem. So Or if you want to just, you will say they have hold it and I want to classify this one and this one. So how much accuracy we have that we can classify and all. So it that problem will say binary classifications and all. Okay. So it's something we have to classify or we can do the predictions and all. Then we have second problem, unsupervised learning. Unsupervised learning, it's something the data is not at all, it's a mix of or bunch of data is there. So in that case, what we'll try to do, we'll do the clustering based upon some properties or similar characteristic. We'll do the first clustering. After that, we can go the dimensionality, what you can say, reduction. Let's say we have the three dimension problems are there, but we don't know, so we'll go into 2D, then we'll go to the 1D and all. We'll try to do, and then we'll solve the problems. And that then the whole agenda will be something to do the classification or the regression only. It's a predictions and all we have to do it. So only thing, one, that the data it was something already categorized. Second one case that when the data is not categorized and all. Okay. Then after we can have one more is there. It's called reinforcement learning. We have now this one. We call the reinforcement, so that will say penalty method, or they will learn from the mistakes. Okay, so so that for that we have some sort of a example: self-driving car, gaming, robot navigation, finance sector, and all. If you talk about what will be the supervised example will be the classification. Classification, what we are doing? Classification, we are going to classify whether the disease is there or not. So this is going to be what we can say detection or email spam detection or image classification or bank loan predictions and all we can do. In the case of regression, we'll do the house price, the what is that will say prediction. In the first year, some price was there, some 10 crore was there. Second year, some 12 crore came. Third year, 16 crore came. So that we can do the prediction in the coming year also. Or maybe the stock price predictions also. What will happen for the stock? It's going up, then suddenly will come down, then it will go. So based upon the characteristic or the change in the behavior of the curves and all that the previous and all that we can do through the regression. So once you will see somewhere that what is a stock analyst and all, they're going to play the what you say straight line. It's called the regression. Okay. And if we talk about what are the example of unsupervised learning, we have search engine, face recognition, targeting, masking, or associated going to rule mining. That's the mining will solve. That's called market-based analysis. That's called sensor data and all. So that will come under the unsupervised because we don't have that categorized data and all. Okay, so now so this is the whole part of that. So in the machine learning part itself, we have the regression. Regression is called something predictions. So now we'll do the statistical modeling for that. Till now, this is just a brief I just gave. So in that, what you can say, statistical modeling, what is the difference of the statistical modeling? Can anyone tell? Something we are going to make a model. Let's say y is equal to mx plus c. It's something that y is going to be a dependent variable, x we have independent variable. So once you are going to make equations, so that we call modeling or any formations of the equations, we'll say statistical modeling. So I think this that the same thing that I explained that what is the machine learning and all, same thing is there, and here we can use it out and all. So in that supervised, we have then we have the unsupervised, then we have the what do you say reinforcement learning and all. Then in that statistical modeling, we will be having two things will be there. One is the regression, second will be the correlation. Can anyone tell the difference between the regression and correlation? How come it going to be different from the each other? Differences in the regression and can you please tell? Regression is something we'll call assessing the specific form of the relationship between the. Yeah, tell me.
So regression means something that one something assumption we are assuming something. Is it so? Correlation means relating with two things.
Yeah, like regression is something we are just trying to get the predictions, or correlation is something how strong there is a something will say that the relation between the variables. Correlation is something will say x and y how strongly they are both are correlated. In the regression, we'll say how mx plus c we can do the predictions how the value will change. Relationship is something. The ultimate objective is to predict or estimate the value of one variable corresponding to the another variable. Is it?
Nice.
Yeah. So in the steps of what we can say regression analysis and all that will do whether the assumptions whenever we are going to deal with the end problems and all we have to deal with the some sort of assumptions whether the data is going to be normal or whether data is going to be a uh, homoscedasticity and all it is there or not because that whole idea of the regression is something we are going to fit the equation mx plus c or maybe y is equal to mx plus c plus error that error is, should be follow the that the normal distributions and all then so then after obtain the equation for the line that line best fit of the sample data so we have to fit this is the that line is there that is the ideal line or it can go from here ideal line how best that the best fit that what we will say MSE is something mean square error it should be minimum and then R square should be somewhere close to 1 so how best data then after we'll check with the strength of relationship that will tell R square if the data is conformed to the linear model use the equations obtain and then we can predict and estimate so here also we'll have some terms will be comes into the picture and all so in that first step in the regression, it will be something we'll call a scatter diagram. So whatever the one is will be the waist circumference, or second one is the deep abdominal atenal. So we are going to get how this values or x values are changing, how it's going to impact the y. So it's a scatter diagram. Play put some. Let's say this is the one y is equal to mx plus c or some error. I'll change the x value accordingly. That y value will change. Will change the again x. Will change the y. Similarly, it's a scatter plot. Now on this only we have to play the one fit line and all. In the fit line also we have to check the what is the that the ideal linear line and all then we'll check with the other things also. Then so for the case of that the linear regression model and all, it's going to be a yi is equal to beta naught plus beta 1 xi plus error. So that beta naught is actually a intercept. Y is equal to mx plus c. The c will show intercept. This m we call slope and then x is the predictor or y is the response variable based upon the x is going to change the y and then that's the error term it should follow the normal distributions then one more is the homoscedasticity like it's something that assumptions will come into the picture okay so what will be there so that the main idea will be a statistical model something will tell that I'll write it a model that describe between the variable using some mathematical equations. Okay, so that the whole purpose will be to understand the relationship. Then make the prediction. So the idea of regression is something to make the predictions and all. So that the general form y is equal to function of x theta plus error. So if we talk about what is the simple regression, so then types of the regression, it's going to be a linear regression, multilinear regression, then we'll come to the logistic regression. Okay. So in the case of simple, what you can say, simple, it's something we'll call y is equal to beta naught plus beta 1 xi plus error. And that error should follow the normal distributions norm. So, so for the whole idea and all, we have to think like what should be the objective function or the things. So what we have to do when we say the prediction. Prediction is something x, the value we have to come close to the x, some x bar or some x that will comes into the picture. So what we have to do for better prediction, what do we do? We have to minimize the error. Is it clear? When I'll say something like I am going to make a prediction. So prediction is something that should come closer to the whatever existing value is there. That's the, let's say I'm going to predict some value that I have taken some sort of that I have think one value 10, and I told you that just predict the value what I am thinking of. So in that case, what we'll try to do a particular model, what they will try to do, they will try to come close as much as possible. So in that case, if the error will be more, so that the what we can say prediction model is not good. So something we have to minimize the error. Okay. So in that case, so loss function or least square estimation will say loss function will say J minimize for the case of beta to beta 1. How? 1 by n, 1 y bar square. It's something that the value y and what we have got the value. So we have to, this one we have to, so our objective is to minimize the sum of the square error model. Because sometimes what will happen when we will, why we are taking the square and all, why? Because when we take the error, it will become the negative positive. If it goes beyond of that, it will become positive. It will be that the less of that is so. So we can generalize with the doing the squares and all. So in that case, so that our the loss function will become how come? I'll take one page actually. Then because we know that L is equal to summation of I is equal to n, it was summation of y minus y bar square. It's something we have predicted it, and this is the something value we have. So in I is equal to 1 to n, it will become yi minus beta xi whole square, because the thing we know y is equal to beta naught plus beta ixi. This is the value. So that will keep here, that we have to minimize it. So to that we all know from the basic of the 12th. So we for the minimization we have to do the take the derivative. For the minimize we have to take the derivative. So we'll take del L by del B naught del L by B1. In terms of intercept, that in terms of we have to equal to 0. So if we are going to what you can say differentiate this one, what we get? Minus of 2. It's something summation of that y I minus beta minus beta I xi. In this case, minus 2 yi minus beta I xi into xi. So this is the things. So let's say this is the equation 1, this is the equation 2. If we solve the equation 1 and 2, if we solve the equation 1 and 2, we'll get overall value. I'll not go like much of more that the derivations. So we'll get beta term, beta 1 term like summation of xi minus x bar, yi minus y bar by summation of xi x bar whole square. And so then beta naught will get from where y bar minus beta bar x bar. So this two equation will say normal equation. Okay. So in that case, assumption it should be linearity because I'm saying linear regression, so it should be a linearity should be there. Second one, independence. Something we call observation should be independent. Then one more is there, homoscedasticity. Constant means variance should be same of residual. Residual is something we call error. Error, you know, what is the error actually? Error is something we will say y I minus y bar. This is the error that will tell residual. It this just I'm trying to make some sort of notes or some like not notes to get the values and then we'll solve one problems also like similar way what we have done also. Then that the normality should be there. Should be there. So these are some assumptions and all it will be there. So now we'll come to the. So now we have defined like how to get the fit line. This is the case. Now we can keep these values and all. We'll get the fit line. From here we'll get the fit line. So once we have fit the line, so that the main idea will be to now check with the error, how much error came, and then we'll check the what is the correlation between the two variables. Is it clear? I think till here it will be that's clear now.
I sir.
Yeah, I'll go. I'll take bit slowly. We'll go because it's something that's a very new for the everyone. So now will be. I'll take the camera also because maybe. So once we have fit the line, in that case, after that, what we have to do? We have to check with the residuals, or we'll say errors. What is the formula for the error? EI will be y minus y bar. That's the predicted value. Okay. So residual sums of a square. Whenever we'll see any problem in the machine learning or predictions and all, they will going to report sum of squares, not the error itself. That's the another picture will be there. Sum of squares. So residual of sum of a square will become summation of I is equal to 1 and yi or what we have predicted it to whole square. That's something we have checked with. That's our loss functions. Okay. So RSS is actually a measure of total square error between actual and predicted value. So, so that the goal will be to that the minimize the error. Then one more term we have that the total sum of square. So it will check total variation in y. That will say explained sum square, explained one. So TSS will become summation of yi bar whole square. After that, we have a estimated or that the variation explained ESS. Variation explained by the model. For this formula, we have ISS will be summation of yi bar minus y bar whole square. So and the formula will be something we'll call TSS will be ESS plus RSS. That will solve some problem. Okay. After that, we have the once we know the error and all what types of error. So now we have to know the relation. So that the relation will go with the coefficient of determination. That we call R square. So R square is something we call measures proportion of variance y explained by x and R square formula will be ESS upon TSS. Something we'll call 1 minus RSS by TSS. So this is the one formula here, second formula here. The first step is we have to fit the line. After that, we are going to check the error. After that, we are going to what is the correlation? What is the correlation? It's called first MSE. That's going to be mean square error. This is going to be a coefficient of determination. So when R square will be the 0, we'll say no explanatory power. R square is equal to 1, we'll say perfect fit. And when the R square is closer to 1, so we'll say better model fit. So now we have checked with we have fit the model, linear regression. Then second step two, we have checked with the error. Now we have checked with the coefficient of determination. Now we have to check with whether the differences are there or not. So it's something we'll say hypothesis testing. Hypothesis testing of beta 1. Okay. In that case, start with the null hypothesis. It will be H naught will be beta. There is no like there is no correlation. Or what you can say, there is no fit something R square is equal to 0. Then alternative hypothesis will be H1 will be something it's not going to be a 0. Is it clear? Then we'll go with the test statistic. And this case, this will become the t-test. So beta 1 that will calculate upon standard error of beta 1. That will calculate. I will tell you how to calculate it now. Similar way, degree of freedom will become number of sample minus 2 and confidence interval will become beta 1 plus minus t at the alpha by 2 at degree of freedom and standard error of beta. I think till here it's clear. Huh?
Okay, sir.
First, we have fit the model. Second, we have calculated the error. Third, we have checked with what is the coefficient of determination, like how much correlated. Then we have done the testing. Then we are going to conclude whether it's there or not. So then we find out the what is the confidence interval also. Okay. So that is the same thing actually. Total deviation, explained deviation plus unexplained deviations and all that we have checked it out already. Then what is the how come it's a correlated when we have one lines are there? It's a unexplained deviation that's the upper of this line. Then explain one. Then the total deviations will be total line. Total. And if we don't have the, this is called the direct linear relationship, and we'll call this is the inverse direct and no linear relationship. So then we have checked with the residuals also. It's something that value and what we have predicted and also. So can we solve one problem? I'll start like whatever the things we have discussed till now will solve the problem. So that the main agenda will be to fit the line y is equal to beta naught plus beta 1 xi plus error. This is the whole agenda is there. So what we have the value? It's x. This is the y. So to calculate that formula we have taken out now. That's the b naught beta and beta 1 formula we have checked it out. For that will be required. So we'll go with the first x bar. What is that? 2 plus 4 plus 6 plus 8 upon 4. 8, 6, 14, 14, 4, 20, 18 plus 20 by 5. Something will come 5. Then we have the y bar. 50 plus 65 plus 80 plus 90 upon 4. We'll get how much? Something called 170, 220, 285 upon 4. We'll get 71.25. Is it? So till here it's clear. Now we'll make the table. What we have table xi, then yi, then we'll be having xi minus x bar, then we'll have yi minus y bar, then the multiplication of xi minus x bar, yi minus y bar, then the square of x minus x bar, because the formula of beta 1 that we all need. What is the value of the 2? What is the value of the 50? X minus x bar, 5 minus 2, it becomes 3. 50, 71.5, it will become 21.25. If we multiply, it will become somewhere 63.75. And x minus x square, it will become the 9. Then we have 4. The value, we can see 2, 4, 6, 8, 50, 65, 80, 90. These values are there. So for the 4, the value of 65, x minus x bar will become minus 1. Y minus y bar 71, it something will become minus 6.25. If we multiply, it will become 6.25 only. And then that a square will become 1. 6, 6 minus 5, 1. No, sorry, this one we have the 80. 1. Then will become 8.75. If we multiply, it will become 8.75. It will become 1. Then we have the 8. This is 90. This is will become 3. This will become 18.75. And if we multiply these two, we'll get 67.75. No, 56.75. This is 9. So now we have compute the what? Beta 1. It's a formula we all know that xi minus x bar, yi minus y bar upon summation of xi minus x bar whole square. Is it correct? So now we have to summation this one, summate this one. How much it will come? 63, 50, 60, 50, 110, 18, 4, 8, 6, 14. So 6, 5, 110, then it become 18, 14, then it will somewhere it will come. Then we have how much? 6, 3, 9, 14, 9, 23, 23, then 133, 135 will come upon 9, 10, 10, 11, 9, 20. It will come how much? 6.75. Is it correct? So now we'll calculate the beta naught. What is the formula? Y bar minus beta 1 into x bar. How come? Just cell. I have the formula y beta 1 plus beta 1 xi. Now what we'll do? We're going to take, it will be same because this is a constant. This is also constant. Now it will become x bar. Okay. Now we have to calculate this one. Beta 1 will become y bar minus beta 1 x bar. We took something similarly, we are taking that's a derivative. So we took the average. So what is the average of y bar? It's something we call 71.5 minus 6.75 that we calculated into 5. 60 into 5, 35, 30. Then we calculate 0.75 into 5. It will come somewhere. So it will become 71.5 minus 33.75. It came 37.5. So I think till here it's calculated. It's clear. Is it clear now?
Nice, sir.
Now we got the value of beta naught is equal to how much? 37.5. Beta 1 we got 6.75. Now we can calculate, we can fit the line. So y I will become 37.5 plus 6.75 xi. So this is our best fit line. So now what we have to do? Next step to calculate the residual. Next step to calculate the residual. Okay. So what we have xi, then we have yi, then we can calculate the yi cap, like that's on the prediction. Then residual, it's something called ei. Then ei square 250. How we'll calculate? X is the 250, 37.5 plus 6.75 into x, how much? 2. How much you will get it? 37. In this one we'll get 51. So now yi, this is the actual value. This is the predicted value. Is there any doubt in this? No, no. That can you able to get it this line? This line, are you able to get it?
Yes.
Okay. 4. Now we have actual value. How much we have? 65. How will calculate the data predicted value? 37.5 plus 6.75 into 4. How much will get it? Will if we calculate, I have the value. We'll get 64.5. Now we'll calculate. We'll get zero point 0.5. 0.25. Similarly, for the 6 also. How much we have? 80. We'll keep 37.5 plus 6.75 into how much? 6. We'll get somewhere value of 78. And if we calculate residual or error, it came 2. And if we go into square, it will become 4. Then we have 8. How much is the value? 90. If we put 37.5 plus 6.75 into 8, it will come 91.5 minus 1.5, 2.25. So now we got the what? We got the value of residual error square. So now what is the going to be the next step? Residual step will be residual sum of squares will become summation of ei square 1 plus 0.25 plus 4 plus 2.25. It becomes So RSS we got. Now we have to get the what? What we have to get? TSS. So in that case, YI we have, what we have? Then we have to calculate YI 71.5. Then YI minus Y bar. YI minus Y bar whole square. So how much is the value? 50, 65, 80, 90, 75, because it will be constant for all. So 21.525 minus 6.25, 8.75, 18.75. Then we can 451.56 to calculate the TSS. TSS 39.06 or 76.56, 350.56. So TSS will become summation of all. If we calculate 451.56 plus 39.06 plus 66.56 plus 351.56, the value came 918.75. So what is the formula for the that's R square? 1 minus RSS upon TSS. 1 minus 7.5, 918.75. It came 1.00875. So value is 0.9918. So it's something R square close to 1. So it's a best fit or something. So now what we have done? Now we have checked with the what you can say. We have fit the line. Now we have calculated the error also. After that we calculated the coefficient of that the determination also. So now the next part will be hypothesis testing. Is it? So we'll go to the next. I'll take one page. Okay. So now we have to do the hypothesis testing. So what is the null hypothesis? Will be beta is equal to 0, means no effect. What will be the alternate hypothesis? Beta 1 is not going to be equal to 0. It's something we'll say two-tailed test. So now we came back to the our. So now we have to calculate the standard error square of beta 1. It's a formula of MSE upon summation of xi minus x bar whole square. This is the one more formula actually we have. We have to remember it. So now we'll calculate the MSE mean square error. What is the formula? RSS upon degree of freedom that we have seen in the ANOVA. Is it? What we have the RSS 7.5. Then how many we have the number of sample? 4. 4 minus 2 is equal to 2. It came 3.75. Then we can calculate the xi minus x square also. We have calculated also already. It's a 20. So now we'll calculate the standard error of beta 1 37.5 20. I think this part is also clear, or shall I explain again? Like how we got this value? This is the formula actually. How we got this value? It's a RSS, not the TSS. We were doing in the ANOVA also. That's the last class. Is it?
Yes.
So, so now we have calculated the standard error also. So now we know the T statistic is we formula we have beta 1 the what we got and standard error of beta 1. What is the value? 6.75 we got the last time. Then 0.433. It came 15.59. So now it's a T calculated. It's a calculated one. So now we can get T tabulated at what? 5% significance level. 0.025 degree of freedom. How much we have? 2. Because the degree of freedom will become n minus 2. 4 minus 2, it will become 2. So if you see the T table, 2 tail test 0.025 of degree of freedom of 2, somewhere the value will come 4.303. It's a from table. Okay. So now we'll be able to say T calculated how much we have greater than of T tabulated. What will do? Reject the null hypothesis. Is it? It's clear? So now we'll go with the confidence interval. We know the formula beta 1 plus minus T of alpha by 2 degree of freedom standard error of beta 1. What is the value of the beta 1? 7 point, no, 6.75 plus minus how much the value we got from the table? 4.303 into how much we got standard error of B1. We got how much? 0.433. If you calculate 6.75 plus minus 1.865, so confidence interval will become 4.885, 8.165 is the limit. So this is the whole regression is there in context of statistical modeling. Hopefully this full problem is clear.
Yes, sir.
Can we do one more problem or shall we move ahead? Or shall I give one problem that you can try at home?
We'll try at home, sir.
Okay. So I'll just explain. Everything is same. X, we have the n is equal to now n4. Then we have monthly sale also there. Y. So first step, calculate the beta 0, beta 1 formula X. And this formula will be having Y bar. Just 1 minute. Someone tried to join now. Y bar minus beta 1 X bar. So this will calculate. After that, we'll fit the line Y is equal to beta plus beta 1 xi. After that, what we calculate? We'll calculate the residual error. It's a RSS, TSS. Then we'll calculate the R square 1 minus RSS upon TSS. Once we are done with that, the next step will be the hypothesis. Then we'll go with the confidence interval. I think that all steps I have cleared now. Is it?
Yes, sir.
Okay, so now the idea will be to move toward the multi-linear regression. Now we were having only one, that the response variable was y, and that what you can say a dependent variable or the independent variable was only one x. Now we'll have the multiple, then we'll check it out how it will going to be a play a part in that multi-linear regression. So that will comes under the assumption will be same. what? Independence will be there. The scores of any particular subjects are independence of the scores of all subjects. Is it? It's something that what we have discussed for the case of just 1 minute. Then we'll have the normality. We all know that when we have this fundamental, then homoscedasticity. It means in the population, the variance of the dependent variable for each possible combination of the label variables are equal. Then the linearity, because we are talking about the mode of linear regression. So this four should be, if we are going to remove some one assumptions, that will lead to the another problem. Let's say it's going to be that the problem is not going to be what you can say, it's not going to be linear. It will become problem with the non-linear problem. If we remove this homoscedasticity, it's again the problem will come into the picture now. So for that, in that case, that's the main idea. We know y is equal to x theta. In this case, it's going to be a like n by 1. It's going to be a n by m. This is going to be a m by 1. In that case, n will be much greater than that of m. Just 1 minute, someone try to again join. Okay. So in that case, we all know that how we're going to find out the x, because it's a matrix. It's not the single variable that we can do, like it's just a, what you can say, play the it's going to linear regression. It's something that equations in terms of y is equal to beta 1 b xi 1 I plus x2 I something will go plus error. So we have multiple x's are there. So what we'll do in that case, how it will become? So in that case, the similar way it will become. So we have to get x value will be something a. Let's say a is equal to xb. So find out the x will become a inverse b. That problem will become like matrix, inverse matrix problems and all. Okay, because we that the here we don't have something we call direct, like we can do calculations and all. In that case, let's say that y is going to be n by 1. It's something we'll call vector of response. So what about the x will become n into p plus 1. P that will say intercept and all. Or maybe the beta p plus n into n. Something called mm. That's what I'm trying to say. And all. Okay. So that how we'll calculate the list square error. That the case of that the linear error, it was L was 1 by n summation of yi minus y predicted, that we have to minimize it. Similar way, because there we were not having, so that we're getting directly here to get the beta 1, it will be something x transpose x minus 1 x transpose y. This is the formula actually to get beta bar. Something we'll call list square. I'll not go into the derivations and all. It's a very lengthy, just what you can say, that's a derivation. Just go through the that formula. We'll say beta naught will be xt into x inverse xt into y. So whatever the model fit and diagnosis, so we have to calculate the residuals. EI will be become yi minus predicted one. Then RSS will become summation of EI square. What about the TSS? Yi minus y bar whole square. What about the R square? 1 minus RSS by TSS. Here, it's not going to be a R square. It will become adjusted R square. Okay. And the similar case will get the value hypothesis also. We'll get H alternate hypothesis, not going to be 0. Similar way, here the degree of freedom will become n minus p minus 1. That p will be the number of x or dependent variable. Then similar way we can get to the confidence interval. I think this is clear now. Or any doubt? Any doubt is there? So because why it will become the r square statistic, like it's something adjusted one, because whenever we have like it's a simple linear or single variables and all, it's going to be like okay, that will play a part. Once it become it's something like we'll say, so it's going to be like they're going to either decrease or decrease. In that case we have to go with the adjusted r square to account and the independent variable to targeting the variables and all. So again, in terms of 1 minus left 1 minute. So R square will not decrease or decrease. It's going to either remains the same or increase with the addition of new independent variables. So it means something that's going to predict it. In that case, when we have to take account of independent variable used for the that the target variable, in that case, we can determine whether the adding new variable to the model actually increase the model fit. So this is going to be n minus 1. N is the number of x, like number of variables, number of samples we have. N minus k minus 1. K will be the number of sample, like that number of, what you can say, multi or in that dependent variables and all we can say. So that the formula will change here. So it's in the case of that's a multi-linear regression, it will become the adjusted R square. So can we solve some problem? Like I'll not go particularly much more detail of it, but will I'll tell you the steps how can we do it. Shall I go ahead with this?
I said,
So in that case, earlier cases what were there? That's the number of sample. Now what we have, size or bedroom. Earlier it was only, let's say that the number of hour they studied and they scored. So it's a simple linear regression. But what we have here, we have x1 and x2, then their corresponding value. The things like we got 2x value. So we want to fit the model of yi is equal to beta naught plus beta I xi plus beta 2x2 plus error. Okay. So this is the whole idea will be there. Now the things will be, I'll take some page. So that we all know the formula of, so that x will become how much? How? 1, 1, 1, 1. Then 2, 3, 4. Because if you see that the number of variables like that would count like this, then x1 and x2. So it will become 1000, 1500, 2000, 2500. Then what we have? 2, 3, 4, 4. 2, 3, 4, 4. Then what will become y? Will become 200, 250, 300, 330. 250, 300, 330. Okay. So now we know the formula. Beta dash will be xt x inverse x transpose y. So x transpose, how much we have? 3 by 4 matrix with 4 by 3 matrices. Is it? So first we'll calculate the xt by x. So that transpose will become 1002, is it? 1500 and 3. 1 2004. 1 2504. Then x will be as it is. If we multiply with this, so first should come x transpose, then it will go to the x. If we calculate, it will come like this: 4 7000. That you can do at home. I think hopefully that you will be able to do it now. How to calculate the how to do the what you can say matrix multiplication, that you know now. We'll take from here one here, then second line will go here, third line will go here, fourth line will go here. So it will come 13 7000 1375 100. Some value will come 13 23500 43. Okay. After that, we have to calculate the xty because we have the formula here, na? This formula that will calculate. That will go. So it will come. It's a x transpose. X transpose is something that we have. 1 1 1. No, not one. It will go to some value will get like this: 10 0 80 0 196 0 0 0 3610. So now we'll get beta bar xt x inverse. Whatever we got here, we have to do the inverse also. So I think that inverse thing that you know. This question will not going to ask in the like our NPTEL examination. I'm just explaining that how it will go. Once you do all multiplications and all, it came two matrix here. No, that's the one matrix here, one matrix here. Then we're going to calculate like it's something 1 by 4, 4, no, no, 4 by 1. It will come like this. So we'll get one matrix. We'll get, let's say, after calculation, we got beta 1 something, some value we get x. Beta 1 also we got some value, let's say y. And beta 2 we got some z. Okay. So now we can fit the equation. Is it? Because I don't have the value. If I'm going to calculate, it will take another 35 or 40 minutes. So now we are, then we'll go with the something called what you can say logistic regressions and all. So it will come y bar will become beta naught plus something we call beta 1 xi plus beta 2 x2. So once you fit the equation, what is the next step? So that the next step will be to calculate the what? Residual error. Then after that, we'll calculate the coefficient of
R square, residual sum square.
determination. Then we'll go with the hypothesis testing. Then we'll go with the confidence interval. I think hopefully this is the process that I explained that is clear. Is it?
Yes, sir.
So now what we have is the logistic regression. Until now, what we have discussed linear regression model
And multi.
called continuous one.
multivariate regression. Yes.
Continuous variables that we're doing some sort of predictions. We were doing linear fit and all. But here what we have, we'll be having some sort of binary item. It's something, it's a categorized value. Let's say x1, x2, x3. This is the black box. That's the input or weight will be there here. This is the weight. This is the input. Then based upon this category, they are going to classify. Logistic regression is something they are going to classify either happy or sad, either success or failure, either yes or no, either 0 or 1. It means there the output will be categorized. Instead of prediction we were doing with that's the linear, here we are classifying in terms of binary, or maybe that the multi-class classifications also comes into the picture. So in that case, what are the assumptions actually will be there? That will be the binary outcome. Okay, and the response of the variable will be either 0 or 1, yes or no, or happy or sad. Something like this will be there. What about the second one? We have the independence. Observation is going to be a independent, that we have discussed in the starting. Then it's going to be a linearity in the logic. Again, it's a something log odd or likelihood and all. When we talk about anything in the logistic or something binary, we have to check with the maximum likelihood. That's the likelihood. Something will say what is the probability of getting the something that we are favor of that. Or there's again one terms will become odds. Odds is something that is the against of what we want and all. Odds ratio that we have checked about and all. So log odds are linearly related to the predictor. Maybe the odds or the logic and all, it should be going to be a linearly related to the predictor and all. So this thing I'll explain again in the coming class, maybe the bit more, not like too much. Then no multicollinearity. It means it should like predictor are not highly correlated. That should means if it's going to be a highly correlated, what will happen? It will try to overfit or underfit the data. Maybe the will get the bias, either positive bias or maybe the negative bias on all will get into the picture. So where we can use it actually? Why logistic regression? Bounded output. It's something either yes or no. Will not go beyond something in the in the linear regression. We were checking from the, it's going to be a continuous line. Okay, it's a continuous, but here we have something we call binary stuff and all. Either yes or either no. That's all. There is no in between and all. Non-linear transformation using the logit function. Logit function nothing. It's a log function. Then interpretable coefficient. Each coefficient reflect the change in the log odds. If we talk about what is the mathematical formulation, I will just tell you. So it's something we'll say probability of getting one at x condition. It's a conditional probability. It will come like 1 by 1 plus e to the power. Again, same equation. Beta plus beta 1 x1 plus something will come to the picture. We'll have probability will be 1 by 1 plus into power minus of beta 1 plus x1 plus beta 2 x2 so on. So this is the statistical modeling. So where can we use in the case of healthcare? To what? Predicted the disease presence, either disease, no disease. Where marketing, customer churn prediction, one churn or return. Education, admitted or rejected based on the scores. Something will say get a score, something. Or the finance, loan, default prediction, one default, zero paid. They will check with the your bank statement or the credit score or CIBIL score and all. They will check. Then manufacturing also, machine failure detection, one is the failure, either the common. So there, that's where we can use it. So it's something we'll do binary. So if we talk about the types of logistics, it's going to regression. Binary will say yes, no, spam or not. Multinomial It's something predict the which food is performed more, veg, non-veg, vegan. Then ordinal. Ordinal is something, it's a Netflix rating or movie rating and all. It's something we are going to movie rating from the 1 to 5. So this is the three types of that the regression we have. It will call, this will call binary classification. Then we'll call multi-class classification. This we have ordinal type. So in that some terms is coming that likelihood function. Again we'll get to some formula is there. Likelihood function is something related to the probability, and it's a lot function that we have to likelihood that we have to maximize it actually. When we told about the error that we should minimize, but here we have to maximize like something that should happen. Then log likelihood. Same thing, we just log it out. Logarithmic. So then after to evaluate the classification things, we have to know about the what is the model evaluation. Let's say it's a predicted one, 0, 1, actual 0, actual 1. When it came actual 0, predicted same came true, positive. Is it? Then actual 1, predicted 0, false negative. Sorry about this. So that the contingency or confusion matrix that we have discussed that in the starting time. When we have the actual 0 but it predicted 1, what happened? It's a false positive. Actual 1, but that one predicted 0, it's a false negative. Actual 1, predicted 1, it's a true positive. Okay. So how accurate are the predictions? So we have that we have to know. It will call accuracy. That is that the model generalizing the well in terms of area under the curve or R1 square or F square and all are the predictor are statistically meaningful or not, means the p value is going to be less than 0.05 or not. Okay. For that, accuracy something will say true positive, true that negative, and summation of all matrix. Whatever we have from the confusion matrix, we have to calculate. Whatever the precision, it's a of all predicted positive, how many were correct. Then the recall is something what we call sensitivity of all actual positive. How many were that's detected. Then F1 is something two times of precision into recall plus that the precision plus recall. It's something that we'll see that will most mostly in machine learning problems only. So here we'll not discuss much more. Then we have the ROC curve. It's going to true positive, false positive rate. Then we'll get, if it is close to 1, we'll get somewhere close. It's something at the various threshold and all. Area under the curve measure overall the performance model. AUC 1, perfect model. AUC 0.5, random guessing. Accuracy, precision, recall, F1. This is the all case of model evaluation for logistic that will sell classification problems. So I think till here, any doubt is there? Can you please tell? Till here, any doubts are there? Hopefully, there is no doubt and all. Now we'll see whatever we have discussed as such will solve some problem. Which of the following best describe the purpose of statistical modeling? Can you please answer what is the purpose of what is the purpose of statistical modeling? To summarize the that's the
See,
last data set. No, no. It's called. Descriptive statistic. It's a mean, mode, median. Is it? So this can't be the answer. To make the prediction based on the observed data. So statistical modeling is actually a purpose to we are going to make a predictions. Yeah, this option is correct. What about the to create the visual representation of the data? No, it's a part of just visual tools only, like histogram, beings and all. It's something after the statistical that modeling will see, not the purpose of a statistical modeling. That's the additional that we have to for better presentation of our the test we have done. Okay, so this is not going to be a to validate the assumption in the experimental design. It's a part of that design of experiment, not the purpose of a threat modeling. So correct option is the B. I think this is clear now.
Yes, sir.
So statistical modeling capture pattern relationship, make predictions, quantify uncertainties. Can you just explain this one? What is the answer? In simple linear regression, what does the slope of regression line represent? Y is equal to beta plus beta xi. What it represent?
B, whether B is the answer, sir.
Average value of the dependent variable. I don't think so. Average value of a dependent variable is the y bar. No, no, it's a predictions. It's related to y. Dependent variable is the something that y is going to depend upon the x. It's a dependent. It's a predictions, not the slope. So this can't be the answer because slope is something I'm saying it's the rate of change of dependent variable for each unit increase in the independent variable. Slope is something we'll say the change, na dy by dx. If m is equal to dy by dx, is it?
Yes. Yes, sir. So,
So this will be the correct option. The intercept of the regression line, no, intercept will be no, it's a beta naught, not the slope. Its intercept is different. Y is equal to mx plus c. So m is the slope. That's going to rate of change. C, it's independent. This can't be. Error terms in the regression mode. No, this is again independent terms. So our option will be the B. Okay. Can you tell for this what is the significance of the intercept in a simple that's the linear regression model? What is the significance of intercept? We have discussed y is equal to beta naught plus beta I x plus residual.
D,
It is always zero? No,
no, sir. D is
not
the
always.
answer.
It is only possible when a line will pass through the origin. Is it? This will become the is equal to mx. Second line, if we pass from here, so this is going to be a y is equal to mx plus c. So this part will show c. So it can be of anything based upon the data. So it is not going to be always. It, it represents the expected value of the dependent variable when the independent variable is zero. Tell me. Yes, that is something that they are
Answer.
going to say. It represents the expected value of the dependent variable when the independent value is zero. It's the correct one. It has no practical meaning. It is there. Practically, they don't have any meaning, but it's a mathematical some sort of meaning is there, na? Mathematically, it's a valid, na. It's told about the shift, how much it shifts is happening from the origin. In the case of QQ plot, we are able to see it's like it should be somewhere, intercept should be there. It is the error terms in the model. No, no. So this can't be the answer. This can't be the answer. This can't be the answer. So this is the correct answer. I think this is clear. So beta naught is the intercept predicted value of y when x is equal to 0. It's something will say y is equal to beta naught plus beta 1 x1. When x is equal to be 0, this term will get valid. So y naught is equal to beta naught will become our predictions. Is it? It represents the expected value of dependent variable. It means y will become the beta naught when the independent variable is going to be a 0. Is it clear? Shall I go ahead? So now the fourth question we have, which of the following is not an assumption of classical linear regression model? Just try to remind what other assumptions I gave. What was the answer? Linearity between the independent and dependent variable, that should be our assumptions is there. So this is the assumptions actually. Homo scaticity of the error. It means variance of the error should be equal for all functions or groups and all. So this is also assumptions only. Errors are independent and normally
Normal
distributed.
distributed.
This is also correct. But
Correct.
they are saying not an assumption. Independent variable must be normally distributed. That can't be. Independent variable y is equal to mx plus c. X can be of anything. Is it? Not
Yes.
always. So this is the assumptions.
Means
This is the assumptions. This is the
it's
assumption. But this not be assumptions. Predictor can be of anything. So we can see key assumptions is something we'll say linearity, relations between the predictor and response should be linear, independence, no auto correlation in the residual, and homo scarcity constant variance of the error, normality of the error, no perfect continuity between the predictor. These are the some assumptions are there. So this is not going to be a. So fourth one is the correct option. Fourth one. What about the fifth one? Fifth we have in the context of residual in the linear regression. What is the typically the first step in diagnosing the fit model? What we have to do? Checking the linearity assumptions. It's something that the premeditated. Is it important? But it's not going to be a plot itself. To for the context of residual, we have that we have to check the another residual plot. This is the before part. Before starting to the fit of the C, our step is the fit, then error, then coefficient of determination like R square. Then we'll go to the hypothesis. When we came to the error or residual, so for the fit itself, we have checked with this. For the fit itself, we have checked with the homo viscosity. And conducting the t test is something that we'll do after the error. Is it? For t test and all, that will do the error. To check with the residual, we have to check with the residual plot. This is the assumptions actually. This is the assumptions actually that we have to check before the applying to the any model. This is the D. Once we'll get to know the error, once we get to the coefficient of determination, then we'll go to the testing. It's something we have to deal with the single plots only. Is it? It's clear? Shall I go ahead?
Yes, sir.
When is it appropriate to use the logistic regression instead of linear regression? Just tell. Where that we have checked it. When we are going to use it out? In the linear regression,
The answer.
like we were checking continuously, continuous. But in the case of logistic, what if we were trying to do? If we go back and then we'll check it here, something, it's a categorize.
Yes, yes.
It's a binary outcome and all. So when the dependent variable will be the categorical, either 0, 1, yes, no, or spam or not, something, it should be categorical. When the residual are normally distributed, it is the assumptions of the homoscedasticity. Is it? When the multicollinearity is present, no, this is again, it's violating the
Assumption.
assumption. When the sample size is large, that's a good, it will good give the good performance, but not giving the logic regarding the logistic regression. I think it's clear. So our answer will be A. In the linear regression, we are going with the continuous dependent variable. Logistic is something category, binary, or multinomial and all. It's a logic or function is there. Okay. That is going to help for that the when the sample is large, it is going to be help for the both logistic regression also or the linear regression also. It's going to help it out, but it's not the reason that we have to shift it to the logistic. That's the logistic regression now. What does the likelihood function represent the in context of logistic regression? Likelihood function. It's a probability of the object data given the parameter of the model. Yeah, it's a for the parameter of the model itself. So this option is the correct actually. Probability of that model is correctly specified. This is the validation, not the likelihood. Something we call p-value or power of the test. So this can't be the answer. The sum of the squared residual. It's a nothing. It's a something we'll talk about the error, not the likelihood functions. It's going to related with the related with the linear regression, not the logistic regression. So this can't be the again answer. The variance explained by the model. It's again not explaining the what you can say likelihood. It's explained the R square value, R square, or maybe the adjusted R square, not explaining the likelihood. So we can see logistic regression was estimated for the beta 1, beta 2 using the maximum likelihood estimation. That is the formula. It's actually a probability of the model parameter, not the variance, not the R square. After this, we'll go to calculate the R square. So I think this can't be the answer. This can't be the answer. I think it's clear. I'm just explaining that why can't be the other options and all. That will be helpful. This concept can be that you can use for the other problems also. Is it? So let's go to the next question.
Yes, sir.
Which of the following are key assumptions for the validity of linear regression model? It's something we have to talk about the assumption for the linear regression model. Tell me what are the options will be there? Homoscedasticity of that residual, correct? Multicollinearity among the predictor, it can be. Not multicollinearity should be not there. Sorry, that's not the assumptions. It's wrong. It will violate the assumptions, yeah. Is it? Normality of the residuals? Yes, it should be. Independence of the error? It should be. Is it? So, our option is the A, C, and
C
D.
and D.
Multi-collinearity should be not there. If it is there, it's going to overfit the data or underfit. It means it will become the bias either side, either with the positive or maybe the negative. So that's a very important terms that we have to know it. If you are going after this course, if you are trying to learn some machine learning course, so then you will try to do with the overfit, underfit, and sometime you will see the bias also and all that picture will come into the picture. Actually, for the machine learning, this course is foundation actually. That if you are entering into the machine learning and all, this course will be very helpful and all because once you do the solve in problem, it's going to help you like in a better way because we'll be having the better grip on the statistic so that we can apply into the machine learning. Even though for the machine learning that we need that is the another context also like that's going to be algebra or something that we all that's called matrix and all that you can help it out but this will be the very helpful actually to uh, that we are going to make any decisions and all. Okay, so classical linear that's a regression. It can be of multilinear or maybe that single linear and all. Linearity should be there, independence should be there, homomorphism should be there, and then residuals also, but not for the collinearity. Okay, what are the consequences of multicollinearity in the multiple linear regression is there? What will happen? What will happen when there is a multicollinearity is there in the problem? Tell me. Just I think I'll give some 2 3 minute time. Increase the variance of the coefficient estimates? Yes. How come? Difficulty in the interpreting the effect of individual predictor because when collinearity will increase, what will happen? There are going to be X and Y. It's going to be heavily related. So it will be a difficult. So that will be the correct answer. Improve the prediction accuracy. No, it will going to reduce. What will happen? It will try to overfit. Potential for the type 1 error. No. Why? Because it's going to get in case the type 2 error, not type 1 error. It's that you can check it out why and how. It's not going, but it's going to increase the variances of the coefficient of estimates and all, and difficulty in the interpreting. It's something if you talk about multi-clonality when two or more that the predictors in the regression models are going to be highly correlated. Okay, what are the consequence? It's going to increase the coefficient estimate difficulty. It's going to decrease or it's going to risk of failure totally. Okay. So, what about the next question? Next question we have in the logistic regression, what are the implications of the high likelihood ratio? There some terms are there that I have missed it out there, not missed it out actually. L null and then L full. It's something will tell similar way it was there, no, 1 minus RSS by TSS and all. Similar way here also because earlier it was the normal, now it's a log. That logit function, logit odd function. Okay. So in the that the logistic regression, what are the implication of the high likelihood of ratio? The model provides a better fit to the data compared to the null model. It means when we have the high likelihood ratio, it means they're going to give the better fit. I told you that's going to high likelihood means it's something that the positive outcome that we are getting out. If it is high odds ratio, it's something that's going to be a negative. Then independent variable explain a significant portion of the variation in the response. Yeah, because when we know high likelihood, then what will happen? They're going to independently they'll explain the significant portion of the responses also. There is a strong correlation between the predictor. No, high likelihood they are predicting better way. It means there is no correlation. So this can't be the answer. Model is overfitted. No, model is not going to overfit. It will become the best model. When we have the high likelihood, it will become the best model, not overfit. Whenever we have the multicollinearity, it is going to be a overfitted. So this can't be the answer. I think it's clear. Shall I go ahead? We have one or two more questions there. Then we'll go. We'll wind up to that today. Shall I go ahead? Okay, we'll go ahead with the one more problem. Which of the following statement is true for the interpretation of what is I'll just hide it. What will happen? In the case of which of the following interpretation statements are true? Which of the following statements are true for the interpretation of f coefficient of in multiple linear regression? What will happen? How come it's they are going to be a interpret the coefficient of with that's going to represent the change in the dependent variable for one unit change in the predictor holding all other predictor constant. Yeah, that's correct only. The coefficient can be interpreted as a marginal effect if there is no multicollinearity. Yes. The sign of the coefficient indicates the direction of the relation between the predictor and the response. Yes. Because why? If it is like this, positive, it's a inverse, there is a no. Magnitude of the coefficient can be directly compared to the determinant of the importance of the point. No. Because it's a coefficient. It's again we have the again another some independent parameter will be there. So we can't directly compare. So this can't be the answer. Okay. So they're going to increase the one unit. Then it will become sign will going to give either positive, either negative. When the multicollinearity, it will become the unreliable. Okay. So now we'll solve or we'll calculate the linear fit. We have the x, y. We have to get beta naught plus beta 1 xi. So what are the steps? We'll do it. What will be the steps? First step to calculate 1 plus 2 plus 3 plus 4 plus 5. 5, 4, 9, 3, 12, 12, 14, 15, 15 by 5, 3. Y bar 2 plus 3 plus 5 plus 4 plus 5 plus 5. 5, 4, 9, 5, 15. How much it will come? Hmm? How much it will come? 19.5, it came 3.8. Now we'll make the table. Xi, yi, then we have xi minus x bar, yi minus y bar, then multiplication, then the last will be xi minus x bar whole square. What is the value? 1. What is the y bar? 2. Xi minus x by it will become how much? Minus 2. And how much? 3.8 and then 2, it will become minus 1.8. Multiplication will become 3.64. Then we have 2. The y bar will be yi, we have 3. Then it will become how much? Minus 1. Minus 0.08. It came 0.081. Then we have 3, 5, 0. Then we have it came 1.20, 0. Then we have the 4. Then we have 4. Then came 1. Then came how much? Point 0.2, point 0.2 and 1. Then 5, 5, 2, 1.2. How much it came? 2.4, 4. So now what will calculate? B1. Formula y, y bar x bar, summation of xi x bar whole square. This summation, how much will get it? It came total 7 by 10.7. What about the beta naught? We'll get y bar minus beta 1 x bar. It came how much? 3.8 minus 0.7 into 3. How much it came? 1.7. What will be the equations? Y is equal to beta naught plus beta 1 x. Beta naught how much came? 1.7 plus 0.7 x. So this is our equations. Is it clear? Shall we wind up? Shall we wind up?
Yes, sir.
Any doubt is there?
Any doubt is there, we'll ask in the next week, sir. When we go through once again, then we'll see. I'll see what is the doubt, sir.
Okay, okay, okay. Thank you.
Okay, okay. Thank you. Thank you so much, sir.